So today we are gonna discuss integration by parts. Have you done this exercise before?
Mm, uh, like a little bit, but not much.
Okay, first of all, let's understand what is the method of integration by parts. As you know,
Hmm.
that whenever we find derivative of the product of two
Mhm.
functions, we call it a
Yeah,
product rule. So
yeah,
first function same. U and V both are functions of x here. U is function of x and V is function of x as well. So both depends upon
hmm
x. So first
yeah,
function same derivative of the second function plus second function same and derivative of the first function. This is called the
yeah.
product rule of derivatives. So from
hmm
this product rule, if we extract out this term, the first term of the right hand side, so it is u dv over dx is equal to
hmm
the left hand side plus minus this term will go to the other side and it will be sign will be changed.
hmm
And if we integrate this last equation both sides with respect to x, integrate with respect to x both sides. So this derivative will be cancelled with integration. The left thing will be u times dv over dx
hmm
equals to u times v, because derivative and antiderivative are opposite to each other, reverse processes of each other. So these will be
Yeah.
cancelled out. We will get uv and negative v du over dx integrate with respect to x. This rule is known as integration by
hmm
parts. By parts. Now, simply when we use integration by parts, we need to know that first thing, why we use integration by parts. Can you hear me properly? Hello? I think I need to change the connection. Wait, give
Your
me
your your camera's frozen.
one sec. I'm gonna change my internet connection.
Yeah,
I think today
that's
is
fine.
today is not a good day for me. I had a lot of problems today. Yes. Can you hear me now?
Yeah, yeah. I can hear you.
Okay. So this rule is called integration by parts.
hmm
So whenever we have a product of two functions, we will use this rule. Simply first function and this is the second function.
hmm
Okay. We can also write this rule in another more easy way. More easy way. Whenever we have two functions and we have to integrate the product of two functions like this. F and g. F
hmm
is a function of x and g is a function of x.
Yeah.
Okay. So
hmm
what is the rule? What is the rule?
Um.
First function same,
Yeah, and then what?
first
Derivative of
function
the
same.
second.
No, integration of the second.
Oh, and integration of the second. Yeah.
So you have to look at here. If dv
hmm
by dx is the second function, then v is the integration of this,
Yeah, yeah.
right? When we integrate this derivative, what we will get? We will get v.
V. Yeah.
So we can write it like this: first function same, integration of second function. After that, we
hmm
have a negative sign, integration. And what is v? What is v? V is simply the integration of the second function.
hmm
And this is the derivative of the first function. And we will integrate once again. So you can write this rule like this.
Okay.
So let's read it again. First function same, integration of
Hmm.
second function minus
Hmm.
integration of this whole function or term inside the bracket, where we have two things, product of two things, integration of second function and derivative of first function.
Okay.
This is the rule.
Hmm.
Okay,
I see.
are you clear with this? So
Yeah.
let's write it once again for more clearance. First function, second function, and we have to integrate the product. What is the rule?
Hmm.
First function same, integration of second function. Okay, minus
Hmm.
integration of this whole. And what is inside this bracket? Derivative of the first function times integration
Hmm.
of the second function. This is the formula, basically. If you
Okay.
know this
I see.
formula, you can integrate any products. Okay, this is for integrating the products of two functions.
Yeah.
Is it clear? Now, one
Yeah.
thing, let me tell you before going to the solving exercises or examples, you need to
Hmm.
understand that what should be the first function and what should be the second function. Means two functions will be given to us, like in example number 16, first function is x, second function is cos x.
Uh-huh.
Like in example 17, first function is x square, second function is log x. Which one should be taken as the first function? X square or log of x? This is the
Um,
question.
I forgot what the acronym was, but I think the log one, right?
Yeah.
Or is the log one?
So you have to you have to get this idea from the right hand side. On the right hand
Mhm.
side, you can see that we are uh, we are taking antiderivative of the second function. We are taking
Mhm.
antiderivative of the second function. So antiderivative of second function should be easy. We should take second function, such function whose antiderivative is easy for us. Okay.
Mhm.
And here we have derivative of the first function on the right hand side. Here we have derivative of the first function. So first function should
Mhm.
be such that its derivative should be easy.
Mhm. Mhm.
So derivative of first function should be easy and integral of second function. Here if we are taking log x as the second function, integration of log x is not easy, is not trivial.
Yeah.
What is integration of log x? So we will take log x as a first function and x square as a second function. This will make this formula look easy, right?
Yeah.
So the rule is first function should be taken such that its derivative is easy, and second function should be such that its integration is easy.
Mhm.
Okay.
Mhm.
So now let's start applying this formula on this example. Let's say, let's add to the new page. Example 17, for example, this one we want to calculate, find.
Mhm.
So how would you start? You will
Um,
say that we will say that we will take log x as the first function and x square as the second function. So we will
yeah.
apply integration by parts. Are you getting?
Yeah.
Okay. Apply the method of integration by parts on this integral. So the formula is first function same,
Yeah.
integration of antiderivative of second function. Clear?
Mhm.
Minus integration of this whole thing. And what should
Yeah.
be inside? Derivative of the first function. What is first function?
Mhm.
Log x
Max.
times
Yeah.
integration of the second function. That's it.
Mhm. And so you're
What is?
essentially integrating the
Yeah.
second function twice. Is that kind of the idea?
Yeah. In this
Okay.
formula, we have integration. Formula is this one. You have to memorize this thing. First function
Yeah.
same, integration of the second function minus integration of this whole thing. What is inside? Derivative of first function times integration of second function. This is
Mhm.
the formula.
Mhm.
This is
Okay.
simply okay. This is simple formula. So we will just do integrations. What is the antiderivative of x square? It is x cube over 3 minus.
Mhm.
What is derivative of log x? It is
1
1
over
over x.
x.
What is
Yeah.
integration of x square? It is x cube over 3. And we will cancel 1x.
Mhm.
And x square over 3 will be left. So we are having x cube into log of x divided by 3 minus 1 over 3 can be taken outside. What is inside? X square. X square has this antiderivative further,
Yeah.
and this can be simplified as x cube log of x divided by 3 minus x cube divided by 9 plus c. That's it. Any
Mhm.
questions?
Yeah. Okay. No, that makes
Okay.
sense. That makes
So
sense.
this is just about this formula. If you know this formula, and
Mhm.
you can integrate simply.
Mhm.
You got this thing, how this formula is obtained from this product rule.
Yeah, yeah, I got that part. Yeah.
Just I have put u equal to f and dv over
Mhm.
dx equal to g.
Yeah.
If this is u and this is g, then I will put f and g here on the left hand side,
Mhm.
and u is equal to f and v is equal to antiderivative of g. Okay?
Mhm.
Because if g is the
Yeah.
derivative, then v is the
Mhm.
antiderivative of g minus, and simply v means antiderivative of g and du over dx means derivative of f. This is simply the same formula if we put u equal to f and du by dv equal to g.
Mhm.
Okay.
Yeah.
This was a simpler formula. This is not written in your book as like this one, formula number 2. You have only formula
Mhm.
number 1 in your book, but you can use it in this way. This is more simple.
Yeah. Yeah. I prefer this way
So,
definitely.
okay. Now let's do one more question, or from the exercise we can solve.
Mhm.
These four examples are given in the book 16, 17, 18, 19, and then we can do exercises.
Yeah. Okay.
Which one we should do? Exercise or example?
Um. I mean, up to you. Do any of the examples look interesting? What would you choose in 18? Because the integral and the derivative are both like e of
Yeah,
x
yeah.
is easy for both.
X square and EX. Add to the
Mhm.
new page. Let's see. We are just discussing a few minutes. So, first function should be used, derivative is easy, and second function is such that its integration easy. So, in
Mhm.
if we have two functions, one is algebraic and the other is exponential, which one should be taken as a first function, algebraic or exponential?
Um, algebraic, or is it exponential? Oh, exponential is easier, right? No, but they're both.
But look at one thing, that if we differentiate algebraic expression, then its degree will be reduced.
Oh, that's true. Mm.
So we are taking derivative of the first function in the formula. So algebraic should be taken as a first function. Exponential
Okay.
function, derivative of exponential function and integration both are same.
Mhm,
So
mhm.
exponential function is never reduced. Whether you
Yeah.
differentiate it or integrate it, it becomes, it remains same.
Mhm.
But whenever we differentiate an algebraic function, it reduces its degree.
Yeah.
So algebraic should be taken as first function and exponential should be taken as second function. And this is the rule.
Okay.
This is the rule. Whenever we have this product, first function should be algebraic. So we will take x square as the first function and ex as the second function. Now look at here, what happens if we apply the formula? What is formula? First function same,
Yeah. Times the integral of the second.
integral of the second minus integral of derivative of
The,
first
yeah.
times integral of second.
Mhm.
Whole integration, whole integral. Okay.
Yeah.
So integral of ex is same ex minus derivative of x square is 2x. Integral of ex is Same EX,
EX.
dx.
Yeah.
Now see, we are again getting the same integral, but with a reduced degree. Earlier we had
Mhm.
square here. It was x square. Now it has become x. So we need to apply integration by parts once again in this question
Oh, okay.
in order to further reduce its degree. Now we have this integral to compute. Now which function should be
Mhm.
taken as the first function again? X
Oh,
should be first
yeah.
function and EX should be taken as second function. So let's apply integration by parts again. First function same, integral of the second function minus integral derivative of the first function times, sorry, times integral of the second function, whole integral.
Mhm.
Any questions?
No, I got that.
X squared EX minus 2 times x. What is integral of EX? Same EX. What is
Yep.
derivative of x? It is 1. What is integral of EX? It is same EX. So
Yeah.
x square EX same minus 2 times x EX minus 1 time EX is EX. EX antiderivative is same EX.
Mhm.
And you are
Mhm.
done. Further you have to
Okay.
multiply 2 inside and this is the
Yeah.
result. Yeah.
Mhm. Okay, so sometimes you have to do it twice. Okay.
Ah, yeah. Clear?
Okay.
So
Yeah.
whenever we have combination of algebraic and exponential, then first function will be algebraic, second will be exponential. This rule
Mhm.
you should remember this rule.
Yeah.
So should we go ahead or what?
Yeah. Let's go ahead.
Okay, another rule
And
we
you just
have
yeah.
whenever we have the product of x algebraic and trigonometric, then algebraic
Mhm.
should be taken as first and trigonometric should be taken as second. Again with the
Okay.
same reason that derivative reduces the degree of algebraic functions.
Mhm.
Okay.
Yeah. Um, I'm just thinking. So, where do logs fall into that? So you
Why
do
do you?
if there was an algebraic and a logarithmic function, you
Yeah,
would
yeah,
choose
yeah.
yeah.
When there is algebraic and logarithmic function, then we choose logarithmic as a first because we cannot integrate algebraic function logarithmic function directly. What is the
Oh
integration
yeah.
of log? How can you integrate this?
You can't,
Do you
can
know
you?
the antiderivative of log x?
Um, no.
No. That's why it should be taken as a
Oh,
first function.
yeah, that makes sense.
Okay, second function should be whose integration is easy or reduces the
Hmm.
degree. First function should
Hmm.
be whose derivative is easy. We cannot take log as a second function. Log should be always taken as a first function because we cannot integrate it. So, by the way, how can we integrate log x? Let's do it.
Integrate Linux. Can we integrate Linux? I don't know
Mhm.
anything whose derivative is.
So, we will put 1 here and we will take log x as a first function and 1 as a second function. Let's apply integration by parts. First function same, integration of second function minus
Mhm.
integral of the derivative of first function
If you still
times the
like this
integral
song,
of second
of
function.
course you app.
Uh-huh.
You can also try unplugging this device and plugging it back in.
What is she? Okay, log
Uh,
x, the integral of 1 is
X.
x minus derivative of log x is
1 over X, yeah.
integral
Times.
of 1 is x. So this will be
Mhm.
cancelled. So we have x ln x minus what is left? 1.
Uh-huh.
So antiderivative integral of 1 is x. So we can take x common. This is the antiderivative of ln x. This
Oh, really?
Yeah.
Okay. Fair
Any
enough.
questions?
I don't know. No, that makes sense.
Okay. These are the exercises in this section. I think all of them are easy just if you know the rules. You know
Yeah.
the formula and you know the rules. Which one should be taken as the first function and which should be taken as the second function, you can do all, all these
Mhm.
questions. If you find any one difficult, you can ask me.
Mhm.
Which one should we do?
Should we do 1D because there's looks like there's 3 different things in that,
Hmm.
and 2 of them are trigonometric, right?
Yeah.
Mm.
So this is x and we have sec x tan x. Let's
Uh-huh.
take sec x. Let's take the product as the second function.
Mhm.
Hmm. And
Oh,
algebraic is the first function. We know that
oh yeah, this,
we
yeah.
know that antiderivative of sec x tan x. We know it, that antiderivative. Whose derivative is this?
It's just sec x, isn't it? Yeah.
Sec x. So that's why I already
Mm.
told you that first function
Mm.
should be such that its derivative is easy, and second function should be such that its integration is, we know the integration actually.
Mhm. Mhm. Okay, that makes
So
sense.
because we know the integration of second function, so let's apply the formula. First function same, integration of second function minus
Yeah.
integration of the derivative of first function times integration of second function.
Mhm.
What is integration of sec x tan x? You said sec x minus. What is derivative of x? It is 1. What is integration of sec x tan x? It is sec x dx.
Yeah.
X times sec x minus integration of sec x dx. What is the integration of
Mhm.
sec x?
I don't know. Is that one?
You don't know?
There's another one for sec squared x, but I don't know the one for sec x. No.
You should know the antiderivatives of all the trigonometric functions: sine x, cos x, tan x, sec x, cosec x, and cot x. All of them.
Um. Um. Yeah. No, I don't know sec x. Yeah. Uh,
Okay, let's do it.
mm.
One way of integrating sec x is you multiply sec x plus tan x in the numerator as well as in the denominator.
Uh-huh.
Multiply this thing sec x plus tan x. Multiply and divide. Can we multiply and divide? Can we do this? Is this legal? Yes, it is legal. Now multiply sec x with sec x, we will get sec squared x. Multiply
Mhm.
sec x with tan x, we will get sec x tan x, and divide by sec x plus tan x.
Mhm.
What is the derivative of tan x?
Um. Oh, the derivative of tan x. Sec squared x is not. Yeah.
What is the derivative of sec x?
Sec x tan x. Oh, okay. I see. I see.
So, do you know any rule when derivative of the denominator is present in numerator and you need to integrate
Mhm.
this function? What is the rule?
Um. Does that not end up with just the same function but add 1 to the power and divide it by the new power?
No.
Or is that the log one?
When,
Is this the log one? Log of the original function.
yeah, the
Yeah, yeah,
log
yeah.
of the original function. So because derivative of the denominator function is present in the numerator, you just take the log of the denominator. That's it.
Oh, okay.
So the antiderivative of sec x is this. One form of the antiderivative is this.
I see. Okay.
Hmm. We have another form of the antiderivative of sec x. There are two forms.
Are they both the
I am
same?
telling you in a while. Just do the
Uh,
exercises. What is next?
um. Oh wait, I see the derivatives. Yeah. Okay. Next. What about ln x squared? In
Yeah,
2D. Sorry.
let's do it. Let's do it.
Hmm.
2D you said?
Yeah.
Let's do it. So what is the idea? We have only one function here. So
Yeah.
which function should be taken as the first function? We have ln x squared, only one function. So we will
Hmm.
take 1 with it as the second function. ln x
Uh-huh.
should always be taken as the first function, right?
Yeah. Hmm.
Let's try this. So take ln x as the first function, integration of second function minus integration the derivative of ln x squared times integration of 1.
Hmm.
So integration. Let's do it. ln x squared. What is integration of 1 is x.
Yeah.
Derivative of ln x squared will be 2 times. Just tell me what is the derivative of this?
Uh, 2 times what? 1 over x.
No,
Oh wait,
2
wait.
times
Okay, 2
ln
times ln x.
x
What?
times
Derivative
1
of
over.
the inside. Yeah. Yeah. Okay. Okay. Okay.
Yeah, this is called general power rule, right? Power will
Hmm.
come down, exponent will come
Yeah.
down, and one will be subtracted from the exponent, and derivative of the inner function will be multiplied. Okay, what is the
Mhm.
integration of 1? It is x.
X again.
So
Hmm.
x will be cancelled. What is left?
Um,
What is left
X ln x
inside?
squared. Integral to ln x. Oh.
Yeah, we have just calculated this. We have just did it. It was equal to what?
It was equal
Uh,
to.
Let me tell you this one.
Oh yeah, yeah. X ln x
Yeah.
minus 1.
Okay.
Okay.
Can I put it now? Can I put it directly?
Hmm. Oh yeah, yeah. Surely.
Okay. We already know that this is equal to x times ln x minus 1. This
Hmm.
and done.
Okay,
Yeah.
that makes sense. Though. Uh, It's quite a lot to think about. What about 3e? That has actually just like
Three.
3 separate things in it, doesn't it?
Yeah. 3e.
Yeah. 2x squared
3e. Okay.
squared x.
Yeah. There are three things. Let's try this.
Hmm.
Let's give it a try. Go to a new page. So again, there are three things. One is algebraic and rest is trigonometric function. So you know
Hmm.
the antiderivative of this function is easy. Antiderivative of sec square x tan x. How would you integrate this?
Um,
What is antiderivative of sec square tan x?
Sec squared tan x. Sec squared is just. Oh, yeah. The derivative of sec squared is tan x. Yeah. Okay. The integral. Sorry. So this is just function multiplied by its differential. So it's just the function itself, isn't it? So it would just be 10x, right?
10
But
square x
squared.
divided by 2.
Yeah.
One way is 10 square x divided by 2.
Wait.
Hmm.
As in the integral would be 10 squared x divided by 2.
I can write it like this:
Oh,
10x sec square x dx. Derivative of 10x is available here. So we
yeah.
can just add power and divide by 2. One way is
Oh,
this.
yeah. Mhm.
Okay. The other way is you can write like break one sec x and give it to 10x so that the derivative of sec x is available here. Now you can also write it as sec square x divided by 2. Now it's up to you which one you use.
Oh, are they equal?
Yeah.
Huh.
Both are equal.
In that
You can
case, let's use the 10x one, right?
this one.
Or does
We
this question for the
we will
question or not?
use any one of them. So let's apply the
Okay.
integration by let's apply integration by parts
Mhm.
to this question. So first function it is clear that first function should be algebraic and
Yeah,
second
for sure.
function should be this minus integration derivative of the first function and integration of the second function. So what is derivative of the first function of 2x square and
For
integration of second function?
hello.
Yeah, can you hear me? Hello? Hello?
Oh yeah, I can hear you now. Yeah. Sorry about that. You cut out. That's fine.
So first function is 2x squared and second function is sec square 10x. So
Yeah.
antiderivative, which antiderivative should I choose? Which one of them?
Let's do 10 squared x over 2.
Yeah, I think 10 square is a good one. We will use
Mhm.
this as the antiderivative. So let's
Yeah.
put it here. Antiderivative of this is 10 square x over 2 minus derivative of 2x squared is 4x
Yeah.
times 10 squared x divided by 2 this.
Mhm.
Now we are here. Still
Oh.
we have to integrate. It will be
Mm.
cancelled out. X squared 10 squared x minus. So 2 will be cancelled out with this as well. So 2 is outside and remaining is 2x times 10 square x. So can we integrate which one should be taken as a first function?
Just x.
Yeah, but 10x cannot be taken as a second function because we don't know what is the antiderivative of 10 squared x. Do
Yeah.
we know?
Oh, we should have chosen sec squared.
Yeah, we should convert it in terms of sec squared. We have this
Yeah.
identity 1 plus 10 squared x equals to sec squared x. We will use this identity and put 10 squared equal to sec square minus 1. Okay,
Mm-hmm.
then we are done. So
Mm.
let's change it in terms of sec squared
Okay.
x. So 10 squared x is equal to sec squared x minus 1, right?
Yeah.
Okay. So just
Uh-huh.
break it in two terms now. There are two terms. One is x sec squared x and other is just x. Multiply x inside. Is it fine?
Yeah.
Fine.
Yeah. That makes sense.
X squared 10 squared x
Yeah.
minus. We have two integrals. Separate them. X sec squared x 1 and minus. 2 was here. So 2 will be multiplied with negative sign. It will become plus 2 and x. right?
Yeah.
So this is easy. Antiderivative of x is just simply x squared over 2.
Mhm.
And what about this? This will be first function and this will be taken as the second function.
Oh, I see. I see. Okay.
So let's apply integration by parts
So the
here.
integration by
Yeah. First function is x. What is integration of sec squared?
tan x.
What is derivative of x?
1.
What is
Yeah.
integration of sec squared?
Into tan x. Yeah. Wait, but we can't.
Yeah.
That's just the same problem, isn't it?
No. There's no any problem now. So you see, you can directly apply the integration by parts. First function same, integration of the second function minus
Yeah.
integration derivative of the first function times integration of the second function.
Oh, and yeah, the integral of tan x is like ln sec x, is it not?
Yes.
Okay.
So you are done. Tan squared x minus can be multiplied inside. So this will become plus. You told me that you said that it is log of sec x plus x squared. So you can combine this first term with the last term and take x squared common, and left will be 1 plus tan squared x minus
Oh.
x tan x plus log of sec x. And you can further simplify it. 1 plus tan squared is sec squared minus x tan x plus log of sec x plus c. That's it.
Okay.
Any questions?
Mm-mm.
No?
No, that makes.
Okay, next one.
Um. Uh. Should we do? Oh, actually. What about 3c?
3c.
Yeah.
3c.
It's just really similar to what we've done already. I can't see it from here.
This is both functions are algebraic. Both the functions are algebraic. Let's apply the integration by parts. You can integrate it directly by expanding power 5 of a binomial. One way of doing
Yeah.
this is, yeah, you know how to expand power 5?
Yeah. You do like a n times n c and then r being whatever position it is, and then so on. Right.
Okay, you can use binomial expansion a
Yeah.
plus b power n. You can expand it. You can just see what are the coefficients of power 5. These are for power 2 and for power 3 and for power 4. These are the coefficients, and for power 5, these are the coefficients. So if sorry, this is 10 again. So these are the coefficients of power 5 if we are expanding a
Yeah.
binomial. So 3 plus 2x power 5 will be 3 plus 2x power 5 will be 3 power 5 plus 5 times, reduce the power of first term and increase the power of second term, plus 10 times 3 power 3 and 2x power 2, plus 10 times 3 power 2 and 2x to the power 3, and 5 times 3 power 1 and 2x power 4, and finally 2x power 5. This is the expansion of this.
Yeah.
Yeah. So one way
Mm-hmm.
of doing this is like this. The second way is you can integrate by parts.
Mm-hmm.
Which one should be taken as the first function? Quickly, just tell me. 12 can be taken outside.
Yeah. Okay.
So we will, you know that derivative reduces the degree.
Mm-hmm.
So we
But
want
then,
which degree is smaller? This is smaller or this is smaller? But of course, x square is a small degree. So
mm-hmm.
we will take this as the first function and this as the second function. Let's apply integration by parts. First function same.
Mm-hmm.
What is integration of the
Yeah.
second function?
Um. Are we?
What is integration of this?
It is the same thing to the power 6 over 6 times 2.
Ah,
Right?
exactly. The derivative is not present,
Mhm.
so we need to divide it. Okay?
Yeah.
Okay. So the antiderivative of second function is this 3 plus 2x 6 divided by 6 times 2
Mhm.
minus derivative of first function is 2x. Again, integration of second function is
Yeah.
3 plus 2x power 6 divided by 6 times 2.
Mhm.
That's it.
Yeah.
Let's move ahead and this is 12. Oh, 12 can be cancelled out.
Oh
12
yeah, of
is
course.
here, here, and here.
Mhm.
Okay, in both the terms we had 12 in the denominator, so I just cancel out in both the terms because it was multiplied by 12.
Yeah.
X squared 3 plus 2x over 6 minus this 2 can be taken outside. 2 times integration of x 3 plus 2x power 60x. You see it is simpler now
Mhm.
comparatively.
We go.
We have reduced one power. Earlier it was x square here, now it is x. Again we will apply integration by parts by taking
Mhm.
x as the first function and this is the second function. Again apply integration by parts.
Yeah.
First function same. What is integration of this?
Um. Over 7. Yeah, and then 7 times 2 on the bottom. Yeah.
Derivative of first function is 1 and integration of second is same.
Mhm.
And once again we have to integrate once more.
Yeah.
This x squared 3 plus 2x power 6 minus 2 will be multiplied and we see 2 is denominator in the denominator. So we can
Yeah.
cancel it. So x divided by 7 multiplied by 3x power 7 minus into minus plus and 1 over 7 times. What is integration of this?
The integration of that 3 plus 2x to the power of 8 over 16. Yeah.
Yeah, just need to simplify this.
Mhm.
Okay.
All right. So are all the questions then just quite formulaic, or does it get
Yeah.
more
Now,
difficult? Is it just formula, basically?
basically it is a formula. If you know
Okay.
how to apply the formula, which function should be first, which should be second, then you
Mhm.
can do all of these questions. Or if
Okay.
there are three functions, then a couple should be taken as one, like this. This is second,
Yeah.
this is first. Okay, we have done almost all the questions 1, 2, 3. And
Mhm.
4 is left, only 4 is left, in which we have limits as well. These are definite
Yeah.
integrals. We can continue from here. We can do 1 or 2 questions from this exercise as well. Or if you think it is easy for you, you understand everything, then we can just go ahead to the next section. What do you want?
Mm, I mean, why don't we do 4G and then we'll move on to the next
Okay,
section this lesson.
okay. So we will start from 4G in next
Mhm.
class, and we will then go to the next section. All right.
Okay, that works. All right.
Thank you so much.
Thank you.
Take care.
Bye.
Bye.